Okay, honors, this is the second video for today, and this one just expands on what we just talked about, predicting whether or not a double replacement reaction will occur. Now, right at the top here, I told you it's whether or not a solid forms, a molecular compound forms, or a gas forms. Now, we did a series of examples with whether or not a solid forms. Now I'm going to give you one each of an example of whether a molecular compound forms or a gas forms. I have also uploaded this video right here, which I found on YouTube. A lovely young lady made this. It's wonderful. She has a mnemonic device called Castro Bear, which teaches the solubility rules. I'm sure that your next chemistry teacher, which will be probably AP or college, will require you to memorize these and just come back to this YouTube video then, and you'll learn them very quickly. Remember, for you on tests, I'll give you a solubility chart like you've seen on PowerPoint 11.3, slide 29. Okay, so let's do an example each of the other two ways where a double replacement reaction occurs. So hopefully you're getting a little comfortable with these. The nice thing about video is if you don't understand it, you can rewatch it, but hopefully you're starting to gain some confidence with writing these formulas. So I'm going to write down the reactants. Here's sodium hydroxide. And now I want you to pause the video. Obviously this is going to be a double replacement reaction. And let me highlight who's going to switch. And then I want you to pause the video and I want you to try complete this reaction on your own. Okay, hopefully you paused the video and completed the reaction on your own. When you do, you know that this compound here has a -2 charge, so K has a +1 charge, so when you put K in, you're going to need 2 Ks. And then, look what you're making. You have hydrogens and oxygen. Oh, we're making water, and water is a molecular compound. So this is the second example where a double replacement reaction will occur because you made a molecular compound. This will be aqueous. And now I want you to pause the video again and see if you can balance this on your own. Now remember, when you're balancing a compound with water and an OH on the other side, split your water into H-OH. Then you can balance all the hydroxides, the OHs, and the H's separately, and it might help you not struggle with it as much because it's definitely more complicated to balance a reaction that has waters and OHs in it. Okay, so pause the video and see if you can do that. All right, I'm back. When you see an OH here, you have one OH there, one OH there, but look here, you have 2 H's there. That's going to force you to put a 2 there. If you have a 2 there, now you have 2 K's here. Let's put a 2 here, and then I think everything is balanced. I would love to see you, and you could tell me if you got this on your own, but hopefully you put a 2 in front of water and 2 in front of KOH, and hopefully you also have an appreciation for when you add, when you change water to the form HOH, how much easier it is to balance. So this is our example of a molecular compound forming, so then the double replacement reaction will occur. The last example I wanted to give you is when a gas forms. Now, on a test, if you're not looking for a precipitate, I would probably give you a hint that a gas was forming because we don't have enough chemical background to necessarily know if a compound is a gas or not. So I would tell you that it was a gas, or I would give you a hint that it was a gas so that you would know how to predict, okay? So I'm going to write down some reactants again. Aqueous, sodium cyanide, plus H2SO4. Now, we did do some acid naming. This comes from sulfate. Remember, she ate ick and got bronchitis. So ate ick, this is going to be sulfuric acid. Just a little naming. Okay, so sodium cyanide reacts with sulfuric acid. This time I'm not going to highlight which ion switch. I want you to try it on your own. Pause the video, try it on your own to switch the ions and write the rest of the reaction. Okay? All right, hopefully you paused the video and did that. Remember, the more that you work through on your own, the more successful you'll be. It's very easy to watch someone stand and shoot free throws, but until you get out there and try yourself, you don't really know if you know how to do it. Okay? All right, so hopefully this is what you did. You switched the H and the Na. Now don't worry about the H2, that's just part of the compound that balances it out to 0. So we're just gonna switch the H and the Na. When I switch H, and I go to put it in front of the cyanide ion, I know that H has a +1 charge, and the cyanide ion has a -1 charge. Now you may say, well, that's not one of the polyatomics you made us memorize, so how would I ever know that? Well, you can go back over here and you can find out. You know that Na is +1, so this would have to be -1 because this compound was provided for you, and surely if they're providing it for you, they're giving you the correct balanced formula, okay? Or a legitimate formula. Okay, so you know that HCN, that's correct, +1, -1. Now I'm going to get rid of those because remember, you never have charges in your final ionic compound. The charges are just to help you get the right one. Then we're going to put Na with SO4. So what's the charge on Na? +1, and then SO4, remember SO4 2- is sulfate, okay? So SO4 2-. Okay, so I've got a 2- and a +1. I need another +1 there, so this is going to be Na2SO4. Can't leave the charges there because then I'm breaking chemical rules, and that's my formula. Now, in this compound, hydrogen cyanide, that's actually an acid, remember? But anyway, hydrogen cyanide is going to come off as a gas, and you would be told this. And this, sulfates are aqueous. You can look that up on the solubility table. And so therefore, this reaction happens because a gas forms. So now you know the 3 ways that a double replacement reaction will occur. For the precipitates, I would just give you the first 2, and then you would use your solubility table to predict whether or not it would happen. For the molecular compounds and gases, it will be an easier style question. You will kind of be led to it so that you don't have to predict whether or not something is a gas. It takes a few years to get comfortable enough to know when a gas forms and when it does not. Okay, so that finishes the honors component on predicting whether or not a double replacement reaction will occur.